One of the most important applications of the idea of linear momentum is the problem of collisions. The collision happens when two objects move close to each other and we have the contact, or maybe not contact, but the interaction force between these two objects. Okay, and this interaction change the course of the motion of these two objects, and that is a collision. A collision may or may not involve physical contact of two objects. For example, in this figure A, see that the mass M1 and M2 come to a physical contact here, and the contact force is the interaction force between these two masses, and this contact force change the course of motion of these two objects. The mass M1 may move to the right, mass M2 move to the left, but after the collision, the contact force may change the course of the motion. M1 may move back to the left and M2 may move back to the right, or there are more than one situation, but the point is that this contact force that change the course of the motion, and we call this the collision. In this case, there is a physical contact between M1 and M2. But imagine for the second figure B, if we have the particle with a charge, like this is a positive charge, and this particle has a positive charge too. We will study this force in the physics too, but from your high school physics knowledge, you know that the particle with the same charge will repel each other. So what we have is that when these two particles come closer, the interaction force, which now is the electric force, will repel each other, and this interaction force changes the course of motion of these two objects. This particle will move upward like this particle may move downward like this, and this interaction we also call this situation as a collision, even though there is no physical contact. In the second example, there is no physical contact in this situation, but we also call this a collision because the interaction between two objects change the course of motion of the objects. The most important characteristic of the collision is that it happens in a very short time. When we say it happens in a very short time, it means that the interaction between two objects happen in a very short time. This is quite clear for the situation in figure A. That is, the interaction force, which is the contact force, exists only when these two objects touch each other. So this happens in a very short time. Okay. In the second situation, it may be a little bit harder because we know that the electric force is a long range force. So it's not these two objects it's not necessarily contact to each other, but they can feel the interaction between the interaction from the electric force. But we will discuss this in more detail in the next course. But I think, again, from your physics knowledge, you know that the electric force decay with the square of the distance between two charges. So it will decay very quickly. It means that the magnitude of the force will be very large when they are close, but when they are apart, the magnitude of the force will decay quickly. So the important event happen when they are close. These two objects are close, and that happen in a very short time. So we can say in general that the collision happen in a very short time. So what is the significance of this behavior? If we look back to the previous section, we know that the average net force is equal to the impulse divided by the time duration that the force act, or the force that the time that we have the force on the object. So you can see that if this delta t is small, the average force is large. Okay, so it means that if the collision happen in a very small time, it means that delta t is very small. The collision force, the force from the interaction, or we call it the impulsive force. The impulsive force is the force between the force happen between the collision, happen in the time of collision. It is a interaction, the force from the interaction. So from this characteristic of the collision, we can see that the impulsive force can be very large because it happened in a very short time. It can change the course of motion in a very short time. The point is that the interaction force or the impulsive force can change the course of the motion in a very short time. So, as we discussed before, if you have the same amount of change of the momentum, which means you have the same impulse, but if it happens in a very short time, the impulsive force can be very large. And the point is that it can be very larger than other forces, can be very larger from other forces. can be very large for can be very larger if you compare with the other forces. So the point is that we can ignore other forces, and we can just consider the impulsive force only. Next, the very important property is that the impulsive force in the internal force is the impulsive force is the internal force. So it means that if the impulsive force is very large, we can ignore the external force that may be act on the object during the collision. We can consider only the internal force. The result is that we can say that the impulsive force dominates the collision. And also the impulsive force is the internal force. So if there is only the internal force only during the collision, we have the very important result, that is the momentum is conserved during the collision. So it means that we can use the principle of conservation of momentum to analyze the problem of the collision, and this helps a lot in the calculation. We know that before the collision, if we know the momentum before the collision, we know the total momentum after the collision, and we can use this to analyze the velocity of each object after the collision.